For 5.2, we are focusing on multiplying and dividing rational expressions. We're going to simplify these expressions, and we're also going to focus today on multiplying and dividing. So a rational expression or a rational number is just a number that you can write as a fraction. Okay, in the official definition, the numerator and denominator are both going to be integers. And we know that the denominator cannot be equal to 0 because then the expression would be what? What happens if you have 0 in the denominator? What's the expression? Undefined. Okay? Do you guys need any more time with this part? Okay. All right, so for example 1, it says to simplify, and then we are going to identify any x values for which the expression would be undefined. Okay, so what that means is, in a rational function, you have to find the places where the denominator is not going to equal 0. Or really, you're going to find the values for which it does equal 0, and then we know that those are going to be our restrictions. Okay, so for part A, we have a single term on top, single term on the bottom. You can just reduce your fraction, the 10 over 6. So 2 goes into both, so this would be 5 over 3. For your exponents, if you're dividing, with the exponents you're going to subtract. So 8 minus 4 is going to be 4. Because it is a positive 4, this goes on the top. You can write your answer in a couple different ways. You can either write it as 5x to the 4th divided by 3, or you can write it as 5 over 3, and then the x to the 4th would go in the middle on the side. When would you write the x to the 4th in the denominator? Guys, be up here with me, no matter what grade you're in. When would x to the 4th have to be in the denominator instead of on the top? Yeah, Lauren, do you know?
If the x to the 8th and x to the 4th were like flipped?
Yep. So if the x to the 8th was on the bottom, okay, then the x to the 4th would have to stay on the bottom. Remember, x to the 8th is just like you have 8 x's all multiplied together on the top. X to the 4th is like you have the 4 x's multiplied together. So what's really happening is you are canceling out these factors because what's x divided by x? 1. Okay, so then when you cancel out 4 on the top with 4 on the bottom, you have the 4 that are left in the numerator. Okay? If that was flipped, the 4 would be left in the denominator. Okay? All right, now we have to find places where the denominator would be 0. Well, in this case, your denominator is what? 3. So is there anything I can plug in that would make this 0? No. Okay, so in this case, the domain is all real numbers, which means there are no restrictions. Okay, so if you don't have a variable in the denominator, you don't have to worry about your restrictions. Okay, so some of you already started B and C. For a lot of these, you are going to have to factor. You have binomials, you have trinomials, so factoring is going to be an important part. Remember, when you are factoring, the first thing you want to look for is the greatest common factor, or we think of that as terms that they have in common. You also want to keep a lookout for special patterns, like the difference of 2 squares. We did the difference of 2 cubes. You have perfect square trinomials. And then if those don't happen, you are going to guess and check. When you check, you are using FOIL, okay, to see if that multiplies back. So we're going to do a lot of factoring review today. All right, so in the numerator, I have 3x plus 4. If I notice it's a binomial, two terms, the first thing I look for is the GCF. Nothing goes into 3 and 4. And then I want to make sure it's not a special pattern. It's not. So the top is going to stay as 3x plus 4. On the bottom, I can see I have a trinomial. So I'm going to make my two brackets. The nice thing about factoring this is if I'm starting with 3x squared, what's special about 3? Yeah, it's a prime number. So the only things that multiply to 3 are going to be 3x and x. Okay, then you want to look at the last number. So the last number is a negative 4. Ian, what does the negative tell you? Okay, good. So this means you're going to have one sign that's negative and one sign that's positive. Okay, so you're going to have opposite signs. Okay, you're going to have one of each. The 4, this gives you your puzzle pieces. The only values you can plug in here, it has to be a pair that multiplies to 4. So 1 and 4 or 2 and 2. When you are plugging them in, you are doing your guess and check. Sometimes people forget that when you have a value that is not 1, you have to multiply it when you FOIL. So you might see, oh, if you have the 2 and the 2, 3 minus 2 is going to be 1, which is what we want it to add to. But remember, when you're checking with FOIL, do you guys remember how I do the smiley face, the nose, and then the smile? That's what you're adding together. 2 times x is 2x. This is going to be 3 times negative 2, which is negative 4x. That does not match the plus x that we want. Okay? If I switched them, it would be positive 4x, right? If I switch the signs. So I have to use 1 and 4. Well, if I put 4 here, it's going to get multiplied by 3. So I am going to want to put the plus 4 here and then the minus 1 here. Again, we said opposite signs, so this would be 4x minus 3x, which gives you x. Another clue that you might want to try, the 3x plus 4, is notice that you have the 3x plus 4 on top, right? Now, when you have common factors, you can cancel them out. So, remember that the division bar does separate these terms. This is a factor. You have to do this before you can do anything else. Just like you can divide the x's by each other, if you divide 3x plus 4 by itself, anything divided by itself is what? 1. Now when you do that, I just want 1 slash so that I can read what's underneath it. Okay? Now, we just said, when you divide, you get what? 1. Okay, we'll try that again. When you divide something by itself, what do you get? 1. So then this becomes 1. This becomes 1. 1 times x minus 1 is x minus 1. That stays in the denominator. The numerator is just 1. Okay, so you can't just say it's x minus 1. You have to keep your placeholder there. Now we have to find where the restrictions are. So this is going to be 1 over x minus 1, where x cannot be. Now looking at this, I hope we can look at that and already see that what can x not be for this? 1. Because if you plugged in 1, what would the denominator be? 0. Remember earlier I said we have to be careful because we want to make sure that we find all the values that would make the denominator 0. So I would not be able to cancel these out if this was 0. Okay, I would have 0 over 0, which is called an indeterminate value. It's something that you look at in pre-calculus and calculus. So once you factor this, right away, it's the entire denominator that can't be 0. So if your denominator can't be 0, you're going to have to set both of these. The 3x plus 4 can't be 0, and the x minus 1 can't be 0. So not only can x not be 1, which is what we do see in the last step, but we also are going to solve this, which, can we do that in our head, moving it over? Subtract -4, divide by 3. So x cannot be -4/3. Okay, so we're going to say we have 1 over x minus 1, where x cannot be 1, comma, -4/3. Okay, so you have to include both of those. All right, for part C, the first thing we want to do is factor. Okay, so I'm going to give you a minute to work with your group so that you can factor those. Now, factoring these is going to take a little more effort. Why? But why? Why is this going to take more effort than the one that we had in the last one? Yep. So to make 6x squared, you can either have 3x and 2x, okay, or you can have 6x and x. So we're just going to do some guessing and checking. Now, the nice thing is, on the top, the last number is 2, and it's a positive, and this is a positive. So if it's positive, you just take the sign of the middle. And what are my only two options? I either have, 1 and 2 or 2 and 1, right? So if it's like 1 and 2 here, whoa, that's going to be too big, right? 12 and 1 would be 13. All right, well, if I did this, I would have 6 and 2, which is 8, which is close, but I need 7. All right, so then I can try 2 and 1 here. 2 times 2x is 4x. 3x times 1. Yay, that's what I want, right? Yep. Now, once you have figured out what the top is going to be, use that to your advantage. Now, this won't always work, but if it starts with 6x here and I split this into 3 and 2, my instincts are telling me on the bottom I'm probably going to want to start with 3 and 2, right? Because it is likely that I will get something that cancels out. So now I have -6, which means I have opposite signs, so 1 plus and 1 minus. For 6, it's either 1 and 6 or 2 and 3, and I'm trying to add to -5. Okay, so let's try some things. So if I put my plus 3 here, my minus 2 here, this would be 9x, this would be negative 4x, this would be 5x. Is that what I want?
Negative, so swap.
Okay, so I want the negative. So if I get the positive, you just have to flip the signs. So now I have positive 4x and negative 9x, which will be negative 5x. And there, I'm writing out my checking. I know that some of you can do the checking part in your head. And then from there, you can cancel out your common factors. So 3x plus 2 divided by itself will make 1. So then your final answer is going to be 2x plus 1 over 2x minus 3. You cannot cancel out the two x's. Okay, this is your final answer. The reason why you can't cancel out those is because when you have the fraction written out, what this means is 2x plus 1 divided by 2x minus 3, where you would have to simplify what's inside the parentheses before you could do any kind of division. Okay, so you cannot cancel those out. Those are stuck together. You can only cancel out factors. And factors have to be multiplied. These are added together. Okay? So now I'm going to find out what my restrictions are. So really, if I'm finding out my restrictions, instead of looking at the last step, I don't want to look at my second step. Okay? Or even my first one, but your second one is when you factor it. So the denominator cannot be 0. So I'm going to take the two things that I had in the denominator as my factors, the 3x plus 2 and the 2x minus 3, set them equal to 0, and then solve. So here I would get x equals negative 2/3. Here I would get x is 3 over 2. So I would say this is my final answer, where x cannot equal negative 2 over 3, comma, 3 over 2. Okay, what questions do you guys have for me on that part? That's good? All right, for D, one strategy you can use is to write this in standard form first. Okay, so sometimes they are not written in standard form. So start with the highest exponent. And then if you have a negative in front, you are going to want to factor out your negative. Okay, when you are factoring out your negative, you can also factor out your GCF. Whoa. Okay, so we're going to factor out the negative. And Macy, what's my GCF going to be for the numerator? So what do they both have in common?
I think just one, because, yeah.
So in terms of numbers, yes. But in terms of variables,
They both have an x.
yes.
At least one.
Yeah, so we're going to factor out the negative x. Okay, and then Cam, what would we have left in the parentheses?
X plus 4, x minus 4,
Why does it have to be minus 4?
because you took the negative out.
Yes. So you can always check with distribution. Negative x times x is negative x squared. Negative x times negative 4 is plus 4x. And then we're going to factor the denominator, which I can see is a trinomial. I'm happy because it starts with x squared, so I know I just have x and x. Has to multiply to negative 8 and add to negative 2. So the only way to get 8 is to multiply 2 and 4 or 1 and 8. Which one is going to give me a difference of negative 2? The 4 and the 2, so I can do x minus 4, x plus 2. And then I'm gonna, bless you, cancel out what they have in common. Okay, so I have x minus 4 and x minus 4 that cancel. So I have negative x on the top over x plus 2 on the bottom. Again, you cannot cancel these out. If you have a plus or a minus, okay, you cannot do that cancellation. If it was times 2, you could. All right, so then we also need to find out where the restrictions are. So we have x minus 4 cannot be 0. So x cannot be 4. And then x plus 2 cannot be 0. So x cannot be negative 2. Okay, are you guys remembering to find both of them at the first step? Okay, so I want you to go ahead and try part E. Okay, so Kate, what did you do first for E? Okay, good. So you're gonna factor out your negative x, and what'd you get in the parentheses? X what? Okay. So negative times a positive is a negative, negative times a negative is a positive. Okay, and then Ria, did you already factor the denominator? If not, we can do it together.
I
So,
did 2x plus 1, x minus 3, but I didn't.
you didn't check it, yeah? Okay, so how did you start yours?
How did I start one?
Yeah, your two parentheses.
Oh, with the 2x squared, so that I did 2x in one and x in the other.
Okay, good. And then your factors have to multiply to 3, add to negative 7. What does that tell you about the signs?
Oh, 2 negatives.
2 negatives, so they're both going to be minus. And then the nice thing about 3 is prime. So it's either going to be your 3 and your 1 or your 1 and your 3. Because we want to get up to negative 7, if I put the 3 here, it gets multiplied by 2 to make 6. And then negative 1 times x is going to make my negative 7. And then I can cancel these out. So I have negative x over 2x minus 1. Okay, and then again at this step is where you want to make sure that you get both values that x cannot be. So 1/2 and 3. Okay, now A and B are very similar to what we did in the first part. It just is set up a little bit differently with multiplication. So the first thing you still want to do is factor where possible. Okay, one other thing that is going to be different with example 2 is it tells you to multiply. You still are going to be simplifying, but you are assuming that all the expressions are defined, which means you don't have to identify what the restrictions are. Okay, something that we're going to write as a reminder for this example is you are going to leave all of your answers in factored form. which really you're gonna like because that means you aren't gonna have to like FOIL them out. So you're gonna leave your answers in factored form. Okay, make sure that you do check for the GCF. Okay, so for x minus 3, I don't have anything I can factor out, not even a GCF. On the bottom, I have 4x plus 20. Joe, can I factor anything out of 4x plus 20? Let's check our numbers.
Oh wait, yeah, you can't 4.
Okay, yep, so 4 is the greatest common factor. 2 goes into both, but 4 is the greatest one. And then, Joe, what would I have in my parentheses?
X plus 5.
Good. Okay, so 4 times x is 4x, 4 times 5 is 20. Okay, and then, Alex, do you remember what x squared minus 9 is going to factor into that special pattern? Yep, so what are my two factors going to be? Good. Okay, so x squared minus 9 is the difference of two squares. I'm going to factor that. Sometimes I do put the parentheses on the top. And then I'm going to cancel out my common factors. Now, you guys have all multiplied before and reduced fractions, right? So if you were reducing the fraction 6 over 15, 3 goes into both, right? So you would divide by 3 to get 2 over 5. Well, if you were multiplying 6 over 7 times 1 over 15, couldn't you still do the reducing where 3 goes into both and make this 2 and make that 5? Yes. So the same thing happens here. When you're multiplying, as long as you have 1 on the in the numerator and 1 in the denominator, you're dividing. So that divides to make 1. Okay, so this is 1, this is 1. X plus 5 cancels out with x plus 5. That makes 1, that makes 1. Okay, the main reason why I do write the 1 in is so that you guys remember your placeholder if everything cancels. If everything cancels in the numerator, you are still left with 1. In the denominator, we have 4 times 1 times x plus 3 times 1, which is just 4 times x plus 3. You don't have to distribute that. You're going to leave it in factored form. That is going to be your final answer. Okay, so this is in factored form. Okay, so do not distribute or FOIL there. Okay, so now I want you to try B. Okay, so Damien, will you tell me what you did for 10x minus 40? Did you factor anything out from that?
No, I did.
Okay, so let's start with the GCF. So I'm thinking, oh, is there a number that goes into both 10 and 40?
Yeah.
Yeah.
I notice it now.
Okay, well, yeah, what is it?
It's 10.
Okay, so if I take out the 10, I'd be left with x minus 4, 10 times x, 10 times negative 4. Okay, and then, Tyler, what'd you get on the denominator?
X minus 4, and then times x minus 2.
Good. Okay, so negative 4 times negative 2 is 8. Negative 4 plus negative 2 is negative 6. X plus 3, we're good. And then, Cole, what can you factor out of 5x plus 15?
5.
Yep, and then what you'd have 5 times?
X plus 3.
Good. Okay, so even if they are in the same fraction, this is still division. X plus 3 divided by itself. Okay, x minus 4 divided by itself. So now when you multiply across, on the top you get 10. On the bottom you get 5 times x minus 2. Well, the 10 over 5, you can still reduce that. So we know that 5 goes into 10 how many times? Twice. 5 goes into itself 1 time. So this is going to be 2 divided by x minus 2. All right, so what I'm going to do is show you the homework for 5-2, and I'm going to let you start that.